All right, so today I will definitely want to finish the final bit for equals method. There might be some tracing exercise which I can maybe post some tutorial video for you. Not very long, maybe up to 20 minutes or so. You can definitely follow that to compare with your solution, maybe for later. But let's now see a quick announcement. Not much really, but of course your written test 1 this afternoon. And then if you got any concern about programming test 0 and 1, please consider grading requests if you want to, or if you want to speak to me. I do have my office hour this afternoon, 6 p.m., if you want to speak to me. And your lab 3, please make sure you keep it steady to work on that. And for your programming test number 2, I believe it's also coming. I'll send a guide and practice test for you very soon. And this time, we're also going to arrange a review session for you to go over a solution. But this time, it's going to be over Zoom. But you know, you'll be recorded. But if you can make it, you can make it. But I'll confirm the details a little bit later. All right. Let's now do a very quick recap, and then move on about equals. Today, we're still going to do lots of tracing. I think the best way is, after we talk about the principles about dynamic type, and also how you like which version of the equals method to call, and then we got to do lots of examples to really reinforce our understanding. Let's do that. All right. So from Monday, so what we spoke about was we talked about basically the different phases. Phase number 1 is really about if you're comparing two objects, they are simply the same object in the memory. The addresses are the same. In that case, the equals should really just return true. Case number 1. And case number 2, if somehow the argument object over here, sorry, let me just do this one here, phase number 2. If the argument object called by value, obj, the parameter, is going to copy the address of the argument. If obj happens to be null, and we know that this, the context object, cannot be null, otherwise we would have got null pointer exception, right? That's a discussion we had. In this case, if obj happens to be null, in that case, return false right away, because something that's null cannot be equal to something that's not null. And to really understand about phase number 3, we did this a whole page of example, right? Let me just recap very quickly about the definition for the terms, and then I will highlight very quickly about what you should really pay attention to, and the rest to really digest and really to clarify, ask questions. It will be really up to you. If you don't reach out to me, there's no way. I know you're struggling. All right. So let's take a look. First of all, static type. Whenever you see the declare type, for example, C1 here, C2 here, object here. So these are the so-called declare or static type. Once a reference variable is declared of certain type, you can never ever change it. Under no circumstances you can change it. Okay, number 1. And the static type, number 2, is going to determine the range of methods you can actually call on that particular reference variable. So we spoke about this diagram here. Let's say if you declare the static type to be objects, in that case, you can only call equals method on that for our purpose, right? So if you look at, let's say, O3 over here, declared to be objects, you can only invoke equals method on O3. If you want to invoke something further, typecasting may be something you can try, all right? And versus, if you got O1 and O2 over here, they're declared to be C1 versus C2. In the case of O1, it's declared statically as C1. You can only invoke M1 plus the equals method that's always inherited, from the object class, right? That's kind of the expectation list that we figure out on Monday. So make sure you also review it. It's also very important insight. We have to revisit this again in a slightly like a general way. We'll do that when we talk about inheritance next week. All right. All right, and then we spoke about dynamic type. Dynamic type, you can think about is actually how you trace the code, which you guys will do a lot today in the written test. So think about this is how I would trace it. Oh, this is the way to trace it. Whenever you see any new keyword, it should be followed by the name of some constructor. The constructor name tells you what the dynamic type is. So in this case, you can see O1 initialized to be C1, right? You can see C1 here is the dynamic type. Dynamic type can actually change whenever you need to. Let's see the very critical point here. When I first declare object O3, that one there, O3, initially just pointing to null. As soon as I do, O3 is assigned to O1. That means O3 is going to point to wherever O1 is pointing to. In that way, if you trace it, you can see C1 is the dynamic type. So that means the object right now, the O3 right now has the dynamic type C1. Later on, if I say O3 O3 is assigned O2. I basically said rather than pointing to here, O3 is going to point to wherever O2 is pointing to right here, which has a different dynamic type, which is C2. So we are basically changing the dynamic type of O3 from C1 to C2, right? And when the dynamic type is different, when you try to invoke the method, it's going to call different version, right? So please do revisit this particular page of all the tracing and also definition very carefully. It's going to impact really the way you kind of understand the equals method. All right, but I'll try to remind you, maybe briefly when we need to. Okay, any part you want me to clarify? Any part? I don't mind. Okay, please spend some time. Look at that. All right, and then we talk about two fundamental questions you have to answer. If anything to do with compilation, you only have to consider static type. In this case, dynamic type don't really matter. Okay. And if assuming that the line of method call actually compiles, you somehow want to figure out which version, for example, which version of the equals method is going to be invoked, you have to look at the dynamic type for the context object, like what we said, earlier. All right, so these two are the very important principle that's going to last until the end of the semester. Of course, that will apply to OOP in general as well, beyond this course. Okay, please keep that in mind. And then I will maybe have to write it down again, maybe later when we talk about inheritance. All right, and then, so in the case where static type, declared type is simply just objects, you can put anything on the right-hand side, okay? So there's a reason, like a rationale behind, which I wouldn't touch upon just yet, all right? But for now, you can assume. Whenever I got a static type or declared type to be objects, it doesn't really matter what the right-hand side is. I can assign anything to some object reference variable, all right? And then we talk about typecasting. What I want to clarify just once more, it's very important for you to know. If I say I want to cast O3 to C1, I'm not really modifying the O3 static type, which is declared to be objects. I'm not modifying that. It can never be changed. What I'm doing is O3 is pointing to this object right here. And then I'm creating just an alias pointing to the same objects. However, the cast type C1 is going to become the static type for this particular cast expression. That's what's important. So whenever you're doing typecast, you're not really modifying anything. You're just creating a new address. You're creating a new copy of the same address. And then for that particular copy of the address has a different static type, which you can exploit. All right, so if you look at this expression here, so if I say O3 cast to C1, this entire expression has the static type C1. That's why I can call M1. All right, so that's also something we spoke about in detail on Monday. So again, take a look. All right, and then we talk about phase number 3, right? So you will see the expression here called getClass and getClass, right? So for example, if the context object is pointing to this object here, if the OBJ parameter is pointing to this object here, dynamically, they might be of different types. Maybe one is point V1, the other one is point V2. Dynamically, they're different. So getClass is simply going to return the title of the box, like a dynamic type over here. So the idea is, when you are comparing apple with banana, in that case, it's just not comparable. So you cannot really say they are equal. So return false right away. Right? You can see return false right here. All right? So you can see it's very interesting. So for phase 1, 2, and 3 that we spoke about so far, they simply give you a certain condition satisfying which you're going to return either true or false, right? So you want to understand all these 3 scenarios about why which you really return true or false immediately. All right? And then let's now talk about phase number 4 from scratch, and that will go on, do lots of tracing. Let's now move on to phase number 4, right? Let's start from scratch. So when we talk about phase number 4, it's right here. Okay? That means so far all these if condition evaluate to false. Otherwise we would have returned already. All right? So that would mean this Boolean condition here should be false. This Boolean condition here should be false. And this Boolean condition here also should be false. Let's write it down explicitly so we have a very clear picture about where we are in the beginning of phase number 4. All right. So let's see. For this one here, so this cannot be equal to OBJ. They are not the same objects. So that would mean I got this over here is pointing to some objects right here, and obj is just pointing to another object in the memory, which is know that they're different, right? And then we know that this one, obj is not equal to null. So obj is not equal to null. And that one is easy to see. You can see obj is really pointing to some object, so it's not null. Okay, it's already there. And the last one. This condition here should also evaluate to false. It's actually not equal to. If not equal to is false, that means equals is true. Right? So this will mean this dot get class equals obj dot get class. And what does that mean? That means if I go back to these two objects, that means the title right here and the y right here, they should be the same. But what should they be exactly? We can easily just look at this. This is referring to the context objects. And context object has the type always here. So this is the dynamic type of the context object, this. So we can fill out point v2 right here. And based on this condition here, we know that these two must have the same dynamic type. So this one here should be point v2. Still, they are the same. Yeah, give me one moment. Let me finish this, and then I'll answer your question. Sorry. So this one here and this one here, they should be the same. Yeah, go ahead.
For the equals method, how come we don't make it a point v2 object as the parameter? How can we just make it an object?
Okay, very good question. So the question is more like the question was, and I'll answer. I'll give you a short answer and a long answer as well. Okay, your fellow student question goes like this: the static type of the parameter is actually objects as opposed to point v2. All right. Why are we using object which can accept anything? We can accept string, we can accept person, we can accept vaccine, whatever, right? So it's more like a design issue of your method. So here we just want an equals method to return either true or false. And we want to be tolerating enough to accept any argument type. So let's say I'm a person. I say myself that equals something. If I simply give argument as a chair, in which case I wouldn't reject the comparison. I'll just say person and chair, they're not comparable. I just return false. Right? It's more like a design issue over here. And then a little bit deeper there, if you try to, I'll just hand wave a little bit. That's something that's kind of beyond the scope for this course. If you somehow temporarily change this one here to be, let's say, person, let's say point v2. Okay, let me do it again. If I temporarily change this one to be point v2 over here, okay? If I do that, of course, that means this will only accept point v2 objects. So now if I try, let's say, p1 dot equals, maybe I'll put maybe some, let's say person 1. So person 1 is not really matching point v2. In that case, it is not going to call this version over here. It's not matching the type. What it will do is it will still call the inherited version that's default from the object class. So you're still kind of, it's still beyond your control. You're not really controlling it. So that's not really your purpose, right? Okay. So guys, the part about having this one here being point v2, you don't really need to worry about for this course, but it's some people do that for their own purpose. But what I just said, you can just take it more like some consideration. If you want to look deeper, drop by, we can talk about it. But I think having the object over here as the parameter type is really a design issue. We want to be able to compare point v2 objects with anything else. It's just a matter of returning true or false. Okay? You don't want to reject any object to be compared. All right, and then let's now take a look at this one here. All right, very quickly. Okay, so what we should do now is look at this part here. That's a creative part. You guys will have to write every time. If I look at just this expression here, oh, sorry, right here. So let's now compare some alternative version. Since we know both of them are point v2, So we know that their structure should be something like we got x, y here. We also got x, y here. We should. So now we should compare x with x and y with y for the attribute. We want to compare their contents. So what I can do is, let's try. If I say this dot x equals obj dot x and this dot y equals obj dot y. Because these are declared to be integers, so I can only use equals to compare them. Now, what's wrong with this fragment? Apparently, this alternative version here, we are not really doing any typecasting. As you can see, what we're doing there is we try to do some typecasting and then use other variable. But is this really necessary? So that's really the essence for you to understand phase number 4. Okay, so my question is, that alternative version there in purple, we say this dot x equals obj dot x, and this dot y equals obj dot y. Is it okay? Conceptually, maybe I know what you mean, but is it going to work on Eclipse? Hints for you. Is it even going to compile? For that to compile, we should look at static type. If you look at the static type, this and this is really the context object, so it's point v2. Point v2 has x and y. Calling x, calling y, fine. How about here? Is this okay? When I say obj.x, obj.y, can I write that?
No, it can't be done because you didn't cast point v2 onto object.
Not really cast over here. So, but you're right, this one wouldn't compile, okay? But for different reason, you're good on the right track. All right, let's take a look. Right here, these two, okay? So this will not compile. Also, this will not compile. The way to look at that is obj declared to be object type, right? Parameter declaration. So this is the static type of obj. All right. Now, static type determines the range of attributes or method you can invoke on the reference variable obj. In the object class, do we have x and y? We don't. We only got equals. So wouldn't compile. All right, very important, right? So this alternative version seems to be very convenient. You don't even need to bother with typecast, but it's not going to work. So that's why it's not going to be acceptable. All right. Okay, because the static type of obj is objects, and the object class does not include x and y. All right. However, obj really is pointing to some point v2 objects. So we should be able to do something about it to really say do some tweak about the static type. However, you cannot modify the obj static type. Once you declare its object, you cannot change it. That's the principle. So what we do instead is this critical line. All right. So once you reach phase number 4, this will be the line you must always do. But to understand why, you have to consider the alternative version I said. So what we do is, let's now take a look at this one here. All right. So now let's take a look at this line here. Let me put a star. Okay. Let me write it down separately. So the star here is, I said point v2, I declare another reference variable. I call that other. And then I say equals point v2 cast obj. All right. So now let's analyze this line very carefully. Okay. What we're doing is ultimately we want to somehow have a reference variable other because it has a static type point v2. So we will be able to get into x and y, right? Static type. But where should other point to? Ultimately, other should really point to obj. That's what it should point to. All right. But to do that, we need some typecasting to help us. Let's now do this one here. First of all, let's start with this expression here. What does it really mean when I say I want to cast OBJ to point V2? According to what we said earlier, let's revisit. That means I'm not modifying OBJ. I cannot. What I do is I'm basically creating an alias pointing to just the same objects right here. Okay? That one there is the cast expression. So this is the point V2 and OBJ. Okay? So this one here is a cast expression. Expression of static type point V2. Once you have this alias over here on the right hand side, we are saying that right here, other should copy its address. That means we got another one. Other is here. And other has a static type point V2. So this is what we got ultimately, point V2, other. And we can actually use this reference over here to actually access the X and Y. Okay, let's now recap what's happening here for phase number 4, right? Alternative version, if you simply do obj.x, obj.y, even though obj is really pointing to some point V2 object, but I cannot do it because obj was declared as object. You cannot do it. The only way to do it is by using a typecast. The typecast is going to create some alias of a different static type. Once you got the alias, you simply copy its address into a variable called other, which is right here. And you declare other to be point V2. After that, you will be able to do other.x and other.y. All right, I'll write down here. So right now, other.x and other.y compile. Because the static type of other is point V2. Okay, that's really the important bit. So this would mean when you do your lab number 3, and also for later programming test, whenever you are defining your equals method, phase number 1, 2, and 3 are just routine. I'll show you maybe some way to maybe simplify that slightly, logically, so you can choose between the two versions. But for phase number 4, you always start with the line of doing the typecast right here. You somehow want to typecast the parameter obj into some reference variable that you can actually use. Right? That's always the first line. Okay? But I don't want to memorize it because in the exam or written test, I might ask you something deeper than that. Don't just memorize it. You want to understand why in the alternative version we cannot do it, but in the actual standard version we have to use a typecast. And afterwards, you can just refer to using other. So obj is no longer used in phase number 4 anymore. It just used to be for cast. Okay. All right, question about phase number 4. Okay? Okay, think about it. Right. All right, let's now move on to right here. Let's now trace maybe some code quickly. All right? So let's now try to trace 2 lines. Okay, I'll try to do it more efficiently so you see exactly the stuff you want to look at. So what we have is we got P1, P2, and P3, right? Let's now visualize them quickly. So we got 3 objects. We got P1, we got P2, and also we got P3, right? We got 3 objects right here. So P1, P2, and P3. And you can see they got dynamic type, just point V2. Right? That's the dynamic type. These are the dynamic type. Oh, sorry. The title of the box is the dynamic type. And then let's just put in the value here that they are important. So 2 and 3, 2 and 3, 2 and 3, 2 and 3, 4 and 6, 4 and 6, right? P1, P2, P3. That one's straightforward. And let's now look at line number 10. Right here. All right? So here, we are trying to call P1.equals. So P1 is a context object, which has the dynamic type point V2. So we go to the point V2 version right here. So that's the version we should call. All right. It will be exercise for you to see why all these three phases are going to be bypassed. Because all the evaluation for the condition here will be false. So we don't really get to any of these returns. All right, so that'll be exercise for you. That's something we kind of did last time. Okay, that's something I'll leave to you. So let's say we reach phase number 4. What are we doing here? So for up to this point, you actually get OBJ, the parameter. That one there has the object static type. Let me put it aside. And it's really pointing to P2, the arguments, right? So when you say P1 dot equals P2, you're really comparing P1 and also P2 objects. And OBJ is pointing to just the argument P2, callback value. All right. Let's now visualize what's happening here, right? Let's take a look. Okay, this part here. The typecasting, which we just discussed, let's emphasize once more. What does this one do? All right. This one here is trying to cast OBJ to point V2. So what we do is create an alias pointing to the same objects as pointing to by OBJ. And so that would be the typecast expression. Point V2 and then OBJ, like that. All right? And then we say that we want to create a new variable called other. Other should really copy the address of this alias, right? So other declared to be point V2 should point to just the same objects. So this is the ultimate reference variable we can use for comparison. All right. So now let's try. This dot x is really P1 dot x right here. Other dot x is other dot x over here, 2 and 2. And also this dot y right here. And also other dot y right here. So we're comparing these two values. All right, so we got 2 and 2 and also 3 and 3. True. So this one here is going to be true. It's the detailed tracing you will have to do, right? Just make sure understand what's going on here. So we can see starting from which version of the equals method that's going to be called, and then we talk about how you can trace phase by phase. When you reach phase number 4, you are also need to visualize about that alias being created because of typecast. And then from there, you're going to see how exactly you can compare the different values. Right? Now, the next one is going to be done in a very similar way. Because P2 over here has the dynamic type point V2. So we're still calling the same version. All right? Exercise for you. All right? But this one here, if you look at just the diagram here, 2, 3, and 4, 6. So ultimately, you should really get false because they got different contents. They are different objects. They have the same dynamic type, but their x and y values are different. So equality-wise, they are not the same. All right. So this one here is going to return false, but exercise for you. Try to follow the same procedure to really trace it. All right. Okay, so this one here is going to return false, okay, ultimately. Because you got 2 and 4 and 3 and 6, okay? Exercise for you to trace. All right, question? Okay? All right. Yeah, so this is line 11 actually, right? I just give that exercise. I'll leave the page clean. So take a look at the this one here. Try to visualize, try to do any annotation to help you understand. Okay, you need the practice for sure for the next written test. All right, so let's now go over a little bit summary, right? Up to this point, we are done with all the phases for the equals method. So what remains in the lecture will be just to do some exercises to really challenge your understanding, try to give more insight into equals, and then just do more example. That's it. All right. So let's see how much we can do today. Okay. Let's take about another 10 minutes, and then we'll take a short break. Okay. So now, let's say do a very quick summary about the comparison. All right. So let's now take a look at this one here. So now what I want to do is I want to put the two versions of equals method together. Okay, so let me just see, make sure I'm not on the right notes. Sorry, bear with me. There we go. Okay, this one here. Now, if you just recall, we got point V1, we got point V2, right? Where we got overridden version. Now, I want you to pause for just 30 seconds or so. All right? I want you to compare this line here and also this line over here. These two lines. They both read as P1 dot equals P2, right? However, they have different fragment of code. You should imagine that we might put them in different classes, all right? Well, you may want to start just by asking yourself, in the line number 10, in the red box, which version of equals is being called? In the green box of line number 10, which version of equals is going to be called? That's the first question, right? Anyone would like to try? How about, yeah, give me one moment. How about we start with this? This one here. Which version of equals is going to be called? Huh? Default from? Object class, right? Okay, good. Let me just finish your explanation here. So you can see P1 over here is a context object. You can see P1 was created right here with the dynamic type point V1. So this is the dynamic type, right? So that means it's going to call the default version, point V1. So default version from object is call, which boils down into P1 equals P2, right? The first one. And the second one there, we can answer that. We still talk about P1, the context object. But right now, P1, you can see, is created this way. Over there, you can see for P1, the dynamic type is point V2. It's just different, right? Dynamic type. That would mean we should really call a different version, because point V2, the dynamic type, does have the overridden version. All right, so this one here, the overridden version. The overridden version from point V2 is call. All right, that's the main thing I want to say, right? So I'm just trying to tell you, later on, you wouldn't really have that kind of a context to really tell you exactly maybe all the example are really to do with point V1 or all the example to do with point V2. You have to judge based on the context in the code. Yes?
Would you be able to access like the superclasses method the object with the keyword super?
Yes, you definitely can use a super keyword, but I will delay that discussion. We're going to talk about it thoroughly next week. Yeah, okay, good. All right, any question about this one here? All right, let me do one more thing, and then we'll take a short break, okay? I would like to go back to phase number 2 and 3 and do a very quick exercise. And that could be useful for your written test 1, though, right? It's more like a reviewing short circuit evaluation. Why don't we do that, all right? Okay, for those of you who are paying attention, you really deserve this, all right? Okay, let me copy this one here. Copy, all right? And then I will put it right here. Okay, let's do this one here quickly, and then we'll take a short break. Right here. Okay, that's the overridden version. And I want you to take a look at phase number 2 and 3. Oh, sorry, let me do a little bit better. Right here. You can see that these two phases actually will end up returning false. Right? Given that, the branch action is going to be the same, why don't we try to collapse them into a single branch? Just going to return false. But we're going to be careful about the Boolean condition, of course. There's always a catch. You got to be careful, right? For this, let's now talk about, I'll give you 4 possibilities. All right, 4. All right, multiple choice, and then justify. All right, but meanwhile, I can think about what you're going to do, right? So let me just, to really save some writing, so let's say this. Let me call this condition here. Let me just highlight it, okay? Let's say this, let me make it thinner. This is one condition here. This is just another condition, all right, here. So let me say this is condition 1. And the longer one is condition 2. All right, 1 and 2, verbatim. So now let's say you got choices. I can say 1 and, let me just write down a little bit more carefully. If 1 and 2. Return false. Okay, let me be a little bit lazy. Oh, sorry, that's not the way to go. Okay, not good idea to be lazy. If 2 and 1 also return false. Okay, choice number 3, if 1 or 2 return false. Final choice. There could be more, but I think these 4 should be enough. If 2 or 1 return false. Right? Basically, this part here just return false. We are trying to factor out the return false. It's just about the Boolean condition, how we combine them. Either use an and or. You put 1 first or 2 first. That's really the distinction. All right. So now, which one do you think should be the right answer? Or you think there are multiple ones. So let's say this is A, B, C, and D. The question is, choose the correct options that are going to be equivalent to the original standard version. Okay, I'll take answer first. First of all, just give me the answer.
I would say C.
You would say C? Okay, that's the only correct option. You can choose multiple if you want to.
I'll stick with
C, okay? C and D, okay? C, okay, good. Well, so nobody choosing A, right? A and B, that's good, okay? Because here we are really saying we're going to return false either when this is the case or this is the case. Not really when both are the case. That's too strong. All right? So these 2, for sure, should not be chosen. The wrong logical operator. Good. So now C and D. I definitely agree C for sure. Because in some way, think about what's happening here. This is very important. If I got OBJ and also OBJ here. OBJ here is a method call. Whenever you have a method call, you have the potential risk of null pointer exception. All right? Risk of null pointer exception. So now, if you compare 1 or 2, 1 is OBJ equals null. Short circuit evaluation. If OBJ equals null happen to be true, what does short circuit evaluation do? Skip. You don't get there. All right? Very important, okay? So I'll say this. If true, skip evaluating 2. On the other hand, if you look at option D, we also need to know why it's not a good idea. Option D is really say, I want to evaluate this one first. But what if obj happen to be null? In that case, I will try that right away and get a null pointer exception. And this condition here happened later, which is too late. All right? So this one here, if obj is null, null pointer exception would have occurred. Before evaluating condition 1. All right? So think about this one here. This one kind of show you how you can combine different branches together, but with the logical reasoning behind. All right? So the ultimate answer is this would be only option C. Would be okay. Make sense to you about why D is not the case? Okay, good try. All right? Okay, guys, why don't we take a short break and then no attendance taken for today. Okay? Take a short break. All right, so I want to do, excuse me, I want to do one more exercise and then I'll move on talking about some JUnit method that's to do with the equality. I'll get that. Okay, just one more exercise, please. Okay, so here on slide number 18. So up to now, we learned about the two notions about equality in the reference type. Either you got, right here, you got reference equality, we just use equal to compare address. We know that pretty well. And also we got object equality, just use the equals method to compare the content. So here, when I say compare content, I really implicitly mean we talk about the overridden version, right? Because if that's not an overridden version, if that's default, you still compare addresses, right? When I say contents, I really meant there's an overridden method, like in point v2, all right? Let's now do some logical exercise over here, all right? Before that, okay, quick check. Guys, do you remember there's something called logical implication? Yeah, maybe your math class. Logical implication. There could be either you write P implies Q, or you might write P implies Q, right? Either way, right? I'm pretty sure I've seen that, maybe your math class, right? Logical implication. So let's briefly revisit very quickly, right? We'll need this for this exercise here, okay? So logical implication simply means if P is true, then Q must be true. Implication. It's like if then else, a little bit like that, all right? So it is important for you to know. For this implication here, it's a logical operator. This will be false when a particular scenario. The only way to really make the implication false is this. When P is true, but Q is false. All right, for example, a very cliche example. So if, let's say, something like, it rains implies, let's say, outdoor ground is wet. Implication, right? So now, if I tell you that it rains is actually true. However, the outdoor ground wet is actually false. It's actually dry. That means the original implication here is invalid. All right? So that means here the implication is false. Right? Just a little bit of logic here, right? That's something you kind of learned earlier. So now the exercise I'm going to show to you about equals is I'm going to kind of phrase the question itself more like a logical implication. You're going to figure out whether it's going to be true or false, right? And the only way to get it false is when the P here, which is what we call antecedents and also consequence, right? That's what you learned earlier. Okay, let's see this. Let's now talk about A and B. All right? A here is saying two objects are reference equal. Okay, I'll try to make it more explicit for you. When I say two objects are reference equal, So I'm saying, for example, let's say obj1 equals obj2 is true. That's A. And then when I say here, the second one, the two objects are contents equal. So of course, implicitly, I'm saying I have some overridden version. So here I'm saying, if I try to call, for example, obj1 dot equals obj2, it returns true. Right? So think about A and B kind of in isolation. A simply means obj1 equals obj2. They are the same address. And option B means the equals method, whatever that overridden version is defined, is going to return true. All right? So now, we got two implications for you. All right? Implication number one, we're saying that if A is true, then B is true. We're saying A implies B. Option number two over here, we're saying B implies A. All right? The question is, which implication is false? And the way to make implication false is when the antecedent on the left is true, but the consequence on the right is false. Right? Can you follow what I'm saying here? Well, think about intuitively, which statement is actually not right? One more thing, and then I can maybe take some thoughts. Here we're saying that if two objects have the same address, then their contents must be the same. That's what A is saying. So here, this is saying if the contents of two objects are the same, then they must be the same memory location. Which one does not sound right to you? One moment. I'll let him try. Okay, go ahead.
I would say that B implies A.
Does not sound right, right? Okay, good, awesome. So this one here, yeah, do take some time to think about it. Of course, in the class time, unfortunately, we don't have that much time, to really dedicate enough time for you. But anyway, so this one here is actually not valid. Let's talk about both options first. Okay, why is this one always valid? This one saying if the two objects are reference equal, then they must be content equal. Very easy to see. That's basically phase number one for equals method, if you remember. Okay, so visualize it. If obj1 and obj2, if they simply point to the same objects, and then I say obj1 dot equals obj2, what do I get? True, phase number one. Right? So if they are the same objects, then equals method should return true always if you follow the standard. All right? So the first implication is always valid. What about here? And to really show that it is not valid, we will need some example to really show that. Okay? I'll give you one example. Okay? Now, let's consider two lines of code. Let's now consider line number 6. Let me just see. Yep. Let's consider line number 6 and also line number 7. All right? You can think about line number 6 over here is really checking reference equal. Right? So this is really the A that we're talking about. And line number 7 is really checking for contents equal. So that's really the B that we are talking about, right? And then this is saying if B is true. Is B true? Let's see. P1 dot equals P2. P1 dynamically is a point V2, so we call the overridden version. And then P2 dynamically is also point V2, so we're going to reach phase number 4, right? Let's skip that, right? So now if we compare P1 and P2, you can see their contents are simply 3, 4, and 3, 4. So it's going to return true. All right? That's something we did earlier. I'm just doing a little bit more quickly. So line number 7 is actually going to give us true. All right? That's the antecedents for the implication. And then if we look at line number 6 right here, P1 and P2. they are simply creating using different constructor call. In that way, P1 equals P2 must be false. So what we have is the B here, true implies A, false, true implies false. So this must be false. All right, so now I can justify about the two lines, the two options here. Okay, very quick summary. So this one here, if you got two things that are the same objects, then equals method between those two objects must return true. Okay, always the case. However, if you say that if I know object 1 that object 2 equals method call give you true, it doesn't necessarily mean these two objects are the same in the memory address. They are not. It could be the same, it could be different, right? That's one example for you to consider. All right. This might be a little bit deeper, does require some logic, but don't be too afraid about really logic, because once you get to 2101, 3101, logic will be your friend. Right? You definitely have to use discrete math to really argue so many proofs and also justification. So we try to do some minimum amount, some light amount in this course. Okay. All right, any question about this one here? All right, if that's good, let's now move on with some JUnit test cases. Okay, I want to talk about, you can also look at the slide. You also got the corresponding slide, but I'll just stick to here. Right? We're going to talk about several assertions. Let's start with assert saying, which we kind of did, in the labs and in the tutorial earlier. But let's just revisit quickly. Okay. So assert the saying, and then you will basically get two expressions. Okay. Expression 1, expression 2. Expression 1 and also expression 2. So these two can be any objects. Meaning that you can say assert saying, you simply pass the reference to a point v2. You pass another reference to string. It's okay. It will compile. But of course, they are not different. They are not the same references. So it's going to fail the assertion. Okay. So what's really assert saying doing? By definition, it's going to pass if these two are the same objects, have the same address. Okay. Very easy to define. Basically, you're going to say pass if expression 1 equals expression 2. And it's going to fail if expression 1 is not the same as expression 2. Okay, as easy as that. Okay, that's the definition. And as your exercise, think about why assert the same is simply equivalent to either assert true or assert false, and using these. All right, think about it. That's something we also covered earlier, but you have to just think a little bit more. Okay, so think about why assert true and assert false. Okay, they're the same. Let's do some quick example. So let's do some quick visualization here. Tracing. So we got P1, P2, and also P3. P1 is a point V1 object, right? Dynamic type is point V1. So P1 is pointing to some object over here, point V1. But this one here, we don't really call any method, so we don't need to put a dynamic type, right? I'm just reminding you, but we'll do that a little bit later. And then we got P2, which is just another point V1 object, just different. And then we got P3 over here, and you're going to do this a lot, I'm pretty sure, today in the test, right? When you're trying to do variable assignment, just make sure you know how to copy the address, right? So P3 is going to point to wherever P1 is pointing to. So P3 is pointing to right here, all right? And then let's now talk about the assert the same. So this one here really boils down into P1 equals P3, all right? So P1, P3, they are the same objects, pass, all right? So this one here, pass. And then if you try the next one, if you say P2, P3 assert same, boils down into P2 equals P3. P2 and P3, different objects. Assert same is going to fail, all right? Okay, assert same is really straightforward. Just remember the definition. You're just comparing the addresses of the two arguments, right? OBJ1, OBJ2. Okay, And I'll get to the assert equals for reference type. I need to summarize that for you. But before that, let's talk about a simple case, just to recap. Okay. So if you got assert equals where expression 1, expression 2, they're simply primitive type. For example, you just got integer, I and j, right? Just compare the value. So it's still equals, but for a primitive type. So now in this case, obviously, you can see I is 10, j is 20. Assert equals I and j, not the same, right? Not equals. So this is going to fail. This boils down into I equals j. Because that's false, so it's going to fail, right? Fail the assertion. They're not equal. And let's now talk about reference type for assert equals. Okay? For that, let's now understand something very important. So let's say we got assert equals right here. And then we got expression 1, and we got expression 2. Expression can be a variable. It can be an array indexing. It can be anything you write, as long as they compile. Okay? Very important to note, both of these are reference types. And also can be any type. You can say assert equals point v2 objects and also string objects. They don't need to be of the same type. Assert equals will simply take 2 objects. Right? That's something we said about equals method similarly. Okay? So now, here's the important thing. All right? Given that both of them are reference type, this will boil down into this one here. It's simply the same as assert true. Okay? And then there's a single Boolean expression we have to evaluate, which will be expression 1 dot equals expression 2. All right? Notice that here the order matters. Expression 1, the first arguments will become the context objects for the equals method. Expression 2, the second arguments is going to become the actual argument for the equals. So the order really matters. Okay? Let's now make it even more explicit. If I say there are 2 cases. Case number 1. If I say assert equals, and then I put expression 1 followed by expression 2. Like that. Pretty much like what we just said. And another one. Let's say I swap the order of the 2. So I got assert equals. And here I put expression 2 and also expression 1. All right, I got these 2. All right. And these 2, according to our definition, they're going to invoke the equals method for sure. But the context object is going to be different, right? The first one there, the first argument, expression 1, will become the context objects. For the second one there, the first argument, expression 2, will become the context objects. Right? Let's write it down. So this one here is going to boil down into assert true. And then we have expression 1 dot equals expression 2. Okay? We'll talk about which version that's going to be called in a moment. And then this one will boil down into equivalent to, I should say. Assert true, expression 2 dot equals expression 1. Right? Specifically, you want to pay attention to the first argument. First argument, expression 1, expression 1. First argument, expression 2, and then expression 2. Right? So now, the question is, in general, are these 2 options guarantee that we're going to call the same version of the equals method? Given that we talk about expression 1 and expression 2, are we going to call the same version of the equals? Anyone? Are we? Go ahead.
Well, I would say that it depends on whether or not they're the same type.
Okay, it depends. That's good. That's good. That's good direction. Depends on what. Give more precise. Depends on what.
Well, so let's say that expression 1 has overridden the equals method from the object class, and it would call the one from EXP1.
Okay. So expression 1, expression 2, in general, they might have different dynamic types. In that case, you may call different version. All right. Very good. So here, let's say this. So this will be the version in expression 1's dynamic type. If expression 1 happened to be point v1, for example, in that way, you're going to call the default version from object class. And this equals here, because context object here is expression 2. So that's going to call, for example, the version in expression 2. Always look at the context objects, dynamic type. So this one is telling you the arguments in the assert equals are not symmetric. So you really got to make sure you put the right order you really intend. If somehow the two expressions here have different dynamic type, which one is put as the first argument is going to determine which version of the equals method that's going to be called. Question? Over here? Yeah.
If they're not the same type, then how does the equals method know which attributes to check?
It depends on the version, really. So I would say, thinking this way. First of all, the first level is we want to know which version of the method is going to be called, of the equals. Let's say let's say we go for option 1. Let's say we go for the dynamic type for expression 1, and then we go to, let's say, point v2, and then we basically execute the body of implementation for point v2 equals method there one by one, and then exactly how you compare things you got to define there. Yeah. Good. All right, guys, this page here is very important to really clarify about how you can decide how the assert equals is really related to the equals method, right? They are really related, and the order really matters. All right, let's now do example. Okay, 10 minutes. Okay, 10 or so. Okay, let's now do. Let's now try maybe. Okay, let's try one by one. Okay, so here let's start with. Let me just see. Okay, good. Let's just do one. So let's now do this one here, okay? This one here. So let's try to visualize what's happening. So we got P1 right here. We got P2 right here, right? So P1 and P2, dynamically, they are point V1, right? So what we got is we got P1 pointing to point V1 objects. Point V1. And also P2, it also has point V2 objects. And I don't really have to put in the x and y because I know that the equals method in point V1 is the default version. They don't care about x and y. They'll compare addresses only anyway, right? However, I can put P3. It's going to be point V2, all right? So P3 is pointing to some point V3 objects right here. So point V3 objects right here, right? That one, let's just do x and y, okay? It might be necessary, but may not be. We'll see. 3 and 4. All right, right here. Let's now try to do assert equals, okay? Very carefully. The first one, we put P1 and P2, right? Star. That will boil down into assert true. And then P1 dot equals P2. Okay? And star star. Let me write it down and then we'll talk about both at the same time. That will be assert true. And then I got P2 dot equals P3. Okay? Like that. Okay? So, yes.
How come it says P2's point to a point V2 object and P3's point to a point V3 object?
Oh, I said, oh, because I made a typo. All right, I appreciate that. Thank you. Here, of course, it should be 1, and this one should be 2. Of course, they don't increments. Yeah, that makes sense. All right. And then let's now try to look at the star over here. So let's see, we are going to call P1. P1 has the dynamic type PV1. So that means default version, right? So that means this one here is boiled down into P1 equals P2. P1, P2, different objects, meaning that assert equals over here is going to be false. All right? Okay. And what about star star? Right here. P2 is the context objects. Okay, put it here. So P2 has the dynamic type, also PV1. Right? The same. Now this case, so it also boils down into P2 equals P3. Right? You can see that even though P2 and P3, they have different types right here, but that's okay because the equals method can accept any objects. So that's something we can accept earlier when you compare, let's say, point V2 object with a string, right? Similar idea, right? So here, if you talk about P2 equals P3, I'll just put them in quote so that you know, in Eclipse or in Java, if you write down explicitly P2 equals P3, because they have different types, you will get compilation error if you write it down explicitly, right? That's the point we kind of mentioned earlier. All right, so that one there is also going to give you false. All right. So this one here is also going to be false. Right? Right here. Right, this one here is not too bad because it turns out the first argument here for the assert equals, they are simply have the dynamic type, just point V1. So we just call the default version, which will compare addresses. Let's talk about right here. All right. Now, let's do a little bit more efficiently. All right. We know that all it matters is about the context object, and the context object will come from the first arguments. So here we got P1, P2, and P3, right? I'll make it bigger. Okay. So here, P1, you can see has a dynamic type, point V1. P2 has the dynamic type, point V1. All right. So these two is going to call the default version. Agree? Okay. So these two are going to call these two. Let me put a little bit more notes for you. These two will boil down into P1 dot equals P2, and also P2 dot equals P3. But we know that P1 and P2, they both have dynamic type, point V1, right? So default version. So we are just comparing the addresses between P1 and P2 and also P2 and P3. P1 and P2 and also P2 and P3. They're simply different objects. So all will be false. All right, fail, basically. Okay. So this will fail as well. All right. How about the last one there? All right. The last one there, P3, is the first argument, right? So that one there will boil down into, again, let's now write it down. So let me put star here, okay? That one there is going to boil down into P3 dot equals P2. And P3 has the dynamic type, point V2. So we're going to call that overridden version, all right? So P3 and P2. Now, the overridden version. Okay, let me pause for a moment. Okay, what we have got so far is assert equals P3, P2 is going to call P3 dot equals P2, right? P3 dynamically is a point V2 object. So we know that it's going to call the overridden version, all right? So now, P3 dot equals P2. True or false? If you compare P3 and P2, seems like 3 and 4, 3 and 4. Seems like. Is it going to be true? You want to tell me why it's not true? The dynamic types are different. Can you be a little bit more precise? Exactly.
The dynamic type of B3 is V2 and the dynamic type of B2 is V1.
Yeah, thank you. Exactly. Okay, I think your fellow student was exactly right. All right, guys. So this one here is still going to end up returning false. However, it is returning false simply because they have different dynamic type. All right, I'm going to write down here, but I'm going to go back and check. All right. So this one here, overridden version, is going to return false because different dynamic type. Okay, sorry, let me just put another star here, right? So for this one here, look at phase number 3, where we get a get class method, right? The get class from P3 is going to be point V2. Get class from P2 is going to be point V1. They are not the same dynamic type, so it's going to return false. All right. All right, guys, any questions over here? Good? All right. 5 minutes. Okay, I would like to do one more thing over here, and then we got a little bit more tracing to do, but that's something we can do very quickly on next Monday. Okay, I want to do one thing here very quickly, just to it might help you a bit, when you actually do your lab number 3. Okay, question?
Can you go back to this last group?
I can. Yeah.
So P1 and P2 are the same dynamics, right?
P1 and P2, yeah. Let me just, you're right. So P1 and P2, they have the same dynamic type. That's correct.
But you said that assert equals for both P1 and P2 is there.
That one will fail simply because, okay, good. This one here, assert equals. Which version of the equals will be called? Default or overridden? Default, right? Because P1 over here, which will turn out to be the context object for calling equals, that one has a dynamic type, point V1, which does not have the overridden version. So we're going to use the default version that's going to compare addresses. So now if you look at P1 and P2, they are separate objects. So it's going to fail the address check, right? Another very important thing when you guys study, right? When you look at here, for example, compare this one here and also this one over here. Basically, both of them return false. Return false. But for different reasons. Okay, sorry, I'm running out of space. But for different, there's really no other way if I can. Okay, I'll try my best. For different reasons, right? It's going to be false is here because they are different addresses. It's going to fail over here because it has different dynamic types. You call it different versions. All right. So guys, I may just take 1 minute. I think there's no point to really go any deeper. Okay. So I think when you do lab number 3, maybe over the weekend or maybe after the test today, you may want to take a look at this particular example on the slides. We're going to go over that briefly, maybe on Monday, before we start talking about inheritance. Especially, you may want to take a look at, we got 2 classes over here. Okay. We have one class called person. And then the person has several attributes like a first name, last name, weights and heights. And phase number 1 to 3 are just standard. Everything we have covered already. You got very good foundation for that. And then we simply say creatively, so when we want to compare if 2 persons are equal, compare their measure and also first name, last name, etc. Right? That's something very simple. Okay? What you want to look into is the next class. We got a person and we got another thing called person collector. All right? The person collector basically got an array of persons. Now, how do we define if 2 person collectors are equal to each other? Okay? I'll give you some visual hints over here, but you can take a look at the Java code, and we'll do a little bit tracing on a Monday. Okay? Let's say if I got person collector 1 right here, And that one there has certain array of persons. Let's say this is a person, person 1, and this is another person, maybe person 2. All right? I got another person collector. And then it also has an array of person. And then this one here, maybe person 3. And second person here, person 4. Let's say. So if you remember, we got some counter number of person should be 2 right here. And the number of person here should also be 2. Right? Conceptually, how do we know if two person collectors are equal to each other? First of all, just to see how many person they're storing, compare the NOP value. If one person collector has 5, the other one has 4, no way they are equal. That's the first thing to check. That's something you will see. And the next level. Let's say they have the same number of persons. You basically have to run inside your equals method a loop to go over person by person. So think about we are having index 0, index 1, index 0, index 1. And for simplicity, we simply say, go with index 0 and index 0 here. Look at this person here and look at this person here. Are these two persons equal to each other? Index-wise. If they are, go ahead to the next one. If they are not, you know that there's no way these two person collectors are the same. Right? So that would mean you will need 2 overridden methods in this one for equals. You need an overridden equals method in person. You also need another overridden method in person collector. Right? 30 seconds, and then we're done. Okay? So if you look at the actual code, you may want to look at this one specifically. Okay? Once we get a particular index of the person, call the equals method to see if they are the same. All right? So this will maybe help your lab 3 a bit. All right? Thank you so much, and then I'll see you later today, and good luck.